Hi, hello everyone. This is Nepaliti sir from ANR Academy. Today we are going to discuss the topic functional equations. This topic functional equation has huge syllabus in Olympiad examinations. But in case of JEE mains and advanced level, functional equations interlinked with continuity and differentiability in basic level. So today we are going to discuss about functional equations with single variable and double variable with the help of substitution method as well as how to use partial differentiation to find the function by the given functional equation. Let us discuss today how to handle functional equations. You know that standard functional equations, suppose if you have f of x plus f of y equal to f of x into y for all x comma y more than 0, then what is the functional equation? You know that it satisfies by the function f of x equal to log x to the base a. Log a plus log b, you have log ab. So the functional equation satisfies the function logarithmic, right? Next, suppose that if you have f of x multiplied by f of y equal to f of x plus y, where x comma y they are any real values, then you know that the function f of x is a power x. Exponential function satisfies this functional equation. Why? Because a power m plus n written as a power m into a power n. Next, f of x plus y, suppose f of x plus f of y, where x comma y they are real. If and only if I can write the function f of x as some constant into x to the power of n. Sorry, f of x equal to kx. If suppose, for example, left hand side, if you have f of x plus y, substituting in this, you will get k of x plus y. On simplification, it is kx plus ky. You know that kx is nothing but f of x, ky is nothing but f of y. So this one satisfies the functional equation, and hence clearly y equal to mx, straight lines passing through origin, satisfies this functional equation. These are the fundamental equations. And suppose if you have f of x multiplied by f of 1 by x equal to f of x plus f of 1 by x, x belongs to any real value except 0. Then you know that the function satisfied by this functional equation, that is 1 plus or minus x to the power of n. So these are the fundamental functional equations we know very well. Suppose that if there is a question a into f of x plus f of 1 by x, suppose given as ax, then how can you find f of x. Observe. Here the functional equation with single variable x, and here x any real number except 0. So this is the question. Our aim is to find f of x. I am going to use substitution method for this. This is equation 1. Replace x by 1 by x. Then what happens? Observe. Now the first term become a into f of 1 by x plus f of, if you replace x by 1 by x, 1 by 1 by x become x equal to a divided by x. This is equation 2. Now by solving these two equations we get f of x. Here two unknowns are there, f of x as well as f of 1 by x. Our aim is to find f of x. So we need to eliminate f of 1 by x here. So I am going to remove f of 1 by x first by multiplying equation 1 with a. If I multiplied equation 1 with a, what happens? Observe. This is a square f of x plus a of f of 1 by x equal to a multiplied by ax, that is a square x. Now on subtraction, minus sign here, here and here, a f of 1 by x, a f of 1 by x gets cancelled. Here you have f of x and here minus a square f of x. So if you take f of x common, inside the bracket we get 1 minus a square, and in the right part this is a by x minus a square x. Therefore f of x written as 1 by 1 minus a square multiplied by, this is a by x minus a square x square divided by x. You can simplify this. So this is the functional value f of x, 1 by 1 minus a square multiplied by a by x minus a square x square by x. So by substitution method we can find the function f of x. Let us discuss another question. Suppose if you have the question, find f of x such that it satisfies the functional equation f of x plus 2 times of f of 1 minus x equal to 7 plus x for all x belongs to real. This is the question. How to handle this functional equation? Let us observe just by substitution method itself. There are two unknowns, f of x as well as f of 1 minus x. Replace x with 1 minus x. Now see the solution. In place of x, you are going to write 1 minus x. So what we get? 1 minus x it is. Next here, in place of x, you have to write 1 minus x. So that we get f of 1 minus x plus 2 times of f of x equal to 8 minus x. This is given equation 1 and this is second equation. There are clearly two unknowns, f of 1 minus x and f of x. Our aim is to find f of x, so that you have to eliminate f of 1 minus x. I am multiplying second equation with 2. What happens? Observe. 2 times of f of 1 minus x plus 4 times of f of x. On multiplication in the right hand side with 2, 16 minus 2x we get. And also you have there 1 time f of x Next, 2 times f of 1 minus x, and in the right hand side you have 7 plus x. Now on subtraction, these two terms gets cancelled. 4 f of x, from this you have to remove f of x, so that you will get 3 times f of x, and 16 minus 7, that is 9, minus 2x minus x, minus 3x, and hence f of x become 3 minus x. So in this way we can handle functional equations by substitution method. Let us discuss next question. If suppose the question is f of sin theta plus 2 times of f of cos theta equal to theta, where the angle theta belongs to quadrant 1. Quadrant 1 nothing but theta belongs to 0 to pi by 2, and find f of theta. This is the question. See, this is equation 1. Here you have sin theta, and here it is of cos theta. If you replace theta with 90 minus theta, then sin theta changes to cos theta and cos theta changes to sin theta. Let us substitute theta by 90 minus theta. Then it become f of cos theta. Second term become f of sin theta. In the right hand side you will get just 90 minus theta. Here f of sin theta is multiplied by 2. F of cos theta is multiplied by 1. But here reverse. F of sin theta multiplied by 1, f of cos theta multiplied by 2. If you multiply with 2 here, f of 2 times of f of cos theta plus 4 times f of sin theta, that become pi minus 2 theta. This is second equation. Applying 2 minus 1, what happens? Observe. 2 f of cos theta, 2 f of cos theta gets cancelled. From 4 f of sin theta, you have to remove f of sin theta. That gives 3 times f of sin theta. Next, 180 minus 2 theta, from which you have to remove theta. So, pi minus 3 theta we get. Therefore, f of sin theta become pi by 3 minus theta. And here the aim is to find f of theta. Let some alpha equal to sin theta, theta equal to sin inverse of alpha. Substituting sin theta value alpha, you will get f of alpha. That is pi by 3 constant as it is, theta written as sin inverse of alpha. So that I can write f of theta, that is pi by 3 minus sin inverse of theta. So this is the way of handling functional equations of single variable. Next, suppose that if you have functional equation with 2 variables, suppose the question is, if you have f of x plus y, that is equal to f of x plus f of y plus x square y plus xy square for all x comma y belongs to R. Find f of x. This is the question. How to handle this functional equation? Let us observe. There are two variables, x and y, both belongs to any real values. Let us see by using partial differentiation how to find the functional value. Apply partial differentiation. With respect to y. That means here we have to treat x as constant, remember. What happens? Observe. What I am doing? Partial differentiation with respect to y. This one f dash of x plus y, internal function derivative. Since x is constant, x derivative 0, y derivative 1. Next, f of x, due to x as constant, its derivative become 0. Next, f of y, partial differentiation with respect to y, so that it is f dash y. Next, plus x square constant, y derivative 1. Last term, x constant, y square derivative 2y. So now it can be written as f dash of x plus y, it is equal to f dash y plus x square plus 2 times of xy. Now you have another relation, but in terms of derivatives, right? Now let us suppose y equal to 0. If you put y equal to 0, what happens? Observe. You will get left hand side f dash of x. Next it is f dash 0, x square as it is. Y 0 means the last term becomes 0, and hence f dash x become f dash 0 value. For any function or differential function, if you write x value 0, it become constant. After differentiating the function, if you replace x by x with 0, then what happens? It become constant plus x square. It can be rewritten as f dash x is nothing but dy by dx. In the right part you have k plus x square. Dy written as k plus x square of dx. Now apply integration on both the sides. Integral dy, integral k dx plus integral x square dx. What is integral dy? Integral dy written as y. Integral k dx nothing but kx. Integration of x square, x cube divided by 3 plus integral constant c. You can find integral constant c as well as k depending upon given conditions to the function f of x. So this is the way of handling functional equation with the help of partial differentiation with respect to y. Let us discuss another question. Next, one more question. Suppose that there is a functional equation two times of f of xy equal to f of x whole power y plus f of y whole power x, and x comma y belongs to real values. Also given the condition f of 1 is equal to 2, find f of x. This is the functional equation. Without using partial differentiation, how to handle this, let us discuss now. I am not going to use partial differentiation. I am going to use just substitutions. Here you have f of 1 equal to 2. Nothing but when you write x value 1, automatically the functional value become 2. So the function passing through the point, it satisfies 1 comma 2. Passing through the point 1 comma 2. The meaning here, suppose that if you write x value, suppose that 1, what happens, observe. If I write x value 1 in the functional equation, why? Because clearly f of 1 equal to 2, the meaning here, the function satisfies the point 1 comma 2, the curve passing through the point 1 comma 2. So replacing x with 1, what happens, observe. 2 times of f of 1 into y equal to f of 1 whole power y plus f of y whole power x, implies 2 times, this is f of y, f of 1 value 2, so 2 to the power of y it is. Next plus f of y whole power 1, simply f of y. Due to given condition f of 1 equal to 2, clearly the curve passing through the point 1 comma 2, and hence replacing x with 1, you got this result. On simplification, 2 times of f of y minus f of y become f of y. You will get that as 2 power y, and hence replacing the variable y with x, f of x become 2 to the power of x. So you got f of x value exponential function 2 power x just by substitution method, writing x equal to 1 and y equal to 2. You got this result. So this is the way of handling functional equations with the help of substitution as well as using partial differentiation. I hope you understand everything. We will discuss the same topic, functional equations, with the questions interlinked with continuity and differentiability. Thank you so much.